So welcome everyone to our 19th Northeast Digestion Roundtable discussion. Our guest today is Michael Borman of Natural Upcycling, which is located in New York State, kind of between Buffalo and Syracuse. I want to thank Nedr board member Isaiah Larry from the Lewiston Auburn Treatment Facility for introducing us. Michael has a ton of experience with developing, constructing, and operating anaerobic digesters in farms and food waste applications. So although his experience isn't specific to wastewater solids digestion, he knows anaerobic digestion. He's been working in the field for over a decade. Currently, he is serving as Executive Vice President of Operations for Natural Upcycling. He's managing a fleet of collection vehicles across the Northeast and daily operations as well of the Cayuga Regional Digester, one of their partners, and a huge food waste digestion facility. And he does some consulting on the side, so he's got a ton of experience. He has a degree in agricultural sciences and business from Cornell University. He will be telling you all about his work with anaerobic digestions and lessons learned along the way. We hope we can have a nice chat after where you can ask him some questions and pick his brain. So again, we're recording the session and we'll share it after on the Nedr resource page. And at this time, it's my great pleasure to introduce Michael Borman and let him take it over. He's calling in from the electrical room at his facility. So we're going to make him sit closer to the computer so we can hear him.
Yeah. So thank you for that very nice introduction. I want to thank Isaiah again for kind of introducing us and getting me involved with this. I apologize in advance. As Janine mentioned, my office is being overtaken by some employees right now, so I'm marooned to our electrical room. So if we're having a little trouble with audio, I might be able to move somewhere else. But for right now, this is where I've got to be. So yeah, Janine mentioned in my my bio that I'm my introduction that I'm a executive vice president of operations at Natural Upcycling. So to give you a little bit of context, Natural Upcycling collects about 9 million pounds of food waste per month, or we recycle 9 million pounds of food waste each month. And that's everything ranging from your small coffee shop on the corner that has some coffee grounds all the way up to large food manufacturers who are sending away quality control issued items, tractor trailer loads at a time. So our reach is from for the collection side of things is from all the way from Northern Virginia all the way to Maine. We don't do collections ourselves out in Eastern Massachusetts and Maine, but we have partners that we work with in that region, and they work with us in this region. So on kind of a day-to-day basis, I'm working as a consultant, management consultant at a 1 million gallon digester in Auburn, New York, the Cayuga Regional Digester, which is owned by Generate Capital, San Francisco-based venture capital firm that is really focusing on investing in renewable energy resources, digestion, and solar primarily. So they purchased this facility a few years ago. They're trying to kind of get a management team down here where so they can manage it themselves. In the meantime, my company has an interest in processing capacity. So we kind of have our hands involved in it, kind of guiding them along to how the process should work with digestion as well as processing food waste, because as a lot of you probably know, anaerobic digestion is a complex process, but made even more complex when you try to add in food waste and other variables. So yeah, so to kind of get started, one of the things Isaiah and I spoke about first was, what does it look like to take food waste in at a digester? How does it work? What are the challenges? What are some things that you need to think about before you try to move in that direction? The one key point that people don't really understand in general when looking at food waste, as far as sourcing food waste for either compost or digesters, is that the food waste market is a very cyclical, volatile market. So, we can have a month where, and what I'm saying that is more on a large scale. So a lot of our collections at your grocery store is going to be pretty constant. It's going to fluctuate with holidays and weekends and spending habits. One thing that we didn't really anticipate was, which I think COVID took a lot of people by surprise as far as what were going to be the effects of it. One of the main things that we saw was our grocery sector picked up tremendously. People, I think, panic buying and the grocery chains were trying to, balance that supply and demand and not doing a really great job of it. So a lot of food did end up, coming through us through that period. But more so on the large scale packaged food waste and industrial food waste side of things. Just on an annual basis, it can vary tremendously from month to month, from season to season. So, when you're looking at a digester and how to feed it, the digesters are primarily, creatures of habit. They're living creatures. They're a living being that you're keeping alive, whether it's a food waste digester, manure digester, or a municipal, wastewater digester. It's a living system that you're keeping alive. So they're creatures of habit. They like consistency, and that's the biggest obstacle in processing food waste is it's really hard to get a consistent stream, not only in volume, but as far as the quality of food waste, the gas production potential of food waste, the different stages of the, how much the food waste needs to be broken down from the starting point when it comes into the digester system. To give you an example, we can get a load in of vegetables, a tractor trailer load in of vegetables that got frozen or maybe a recall on it. Run that through our digester. It's going to take a lot longer to break that material down than if we're getting a load of liquid whey or of we get fruit juice, for example, that really has a high conversion rate to methane, and it makes a lot of gas very quickly, whereas some of the other lower strength stuff or higher solids material or more cellulosic material takes a lot longer to break down. So if I feed a ton of that in, it's going to react in the digester completely different than if I feed a ton of this other fruit juice material, for example. So that's consistency is kind of the major challenge in doing that. So one thing I've learned over the years with that is the only way to really combat that lack of consistency and the lack of dependability of specific streams of waste is by having a large buffering capacity. So you want to have large storage tanks that you process everything into that storage tank and have it as one homogeneous mixture, and then you can meter that mixture in on a regular basis, and that larger volume is going to take a lot longer to change in its total value set than if you were going to be feeding a single type of food waste in all at one time into the digester. So that was one of the major lessons learned back in 2008, 2009. Upstate New York or New York State had a large push for on-farm digesters to be built. So a lot of dairy farms were taking advantage of lot of grants and subsidies in installing these digesters, and you know, one thing they quickly learned was that you know, the grants and subsidies only got you so far. They only got you through construction, and then, you know, your operating expenses are going to cost you money on top of that. You know, it has a lot of intangible benefits, and quite a few small financial benefits. And then speaking in terms of an on-farm digester, you know, you deal with a lot of odor concerns. Your nitrogen becomes more plant available. You know, if you can use if you separate the solids after the digestion process, you can use that as bedding, and it can offset some bedding costs. However, when looking at just the electrical production, you know, that's a small kind of cost offset rather than a revenue generating center. So a lot of these farms put these digesters in and found that out kind of the hard way, and started looking to other ways to generate revenue with a digester, and you know, taking in tipping fees from food waste manufacturers or food manufacturers in the form of food waste seemed pretty lucrative. So these farms would bring in a truckload of whey, for example, and dump it right in the pit right before the digester. They'd feed it all in. They'd all of a sudden have really great gas production, and then the next day the system would crash. They'd have a lot of dying off of their bacteria because they had essentially a sugar rush, and it upset the biology of the system. So you know, that was kind of a hard lesson learned by a lot of people. Is you really need when working in food waste, you really need to have a lot of buffering capacity to be able to handle those fluctuations in COD, BOD, you know, volatile solids, and things of that nature. The other kind of thing that is paramount in food waste digestion, I'm not sure in the wastewater world how common it is, but you know, I know in the dairy world it's unheard of. But doing the daily ratio of volatile fatty acids to alkalinity testing is a key metric to know. You know, you don't want too low of a ratio. That means you're starving your bacteria for food. If your ratio is too high, that means you know, essentially you're going to cause an upset. You're going to cause foaming, and you can have a crash on either side of that ratio. And you know, as I started with in the beginning, you know, digesters are all living beings. So every digester is, you know, it's like feeding a cow. Every cow is just a little bit different. You know, like the human body. If I eat a burrito, my body's going to react different than if you eat a burrito. And so you know, every digester is going to react a little bit differently. Sorry, was there a question?
I think someone just joined us. And
oh, okay. Yep, no problem.
All right.
So tell you a little bit more about our company. So you know, on the slide here, the top picture there is one of our collection vehicles. We've got about 30, I think a little bit over 30 trucks on the road right now, doing collections. We collect from a lot of major grocery store chains, Price Chopper chains, Wegmans grocery store chains, Hannaford supermarkets, a lot of kind of smaller size stores there as well, hospitals, things of that nature. We're, you know, on a typical route, you know, one of these trucks can handle between 8 and 12 tons per day. Per truck is about what we're collecting from. And then the picture below that is of our digester in it's at Noblehurst Farms, which is the kind of the parent company of Natural Upcycling. They're in between Rochester and Buffalo, a small town called Linwood. That's an NVTech digester, 2 million gallon complete mix. And that is, they're feeding roughly 10 to 15% dairy manure, and the rest is food waste. So, you know, one of the major aspects of our company here is like I mentioned, the food waste brokerage side of things, of brokering large scale tractor trailer loads of packaged food waste. It's one of the toughest problems to solve in the food waste industry is how do we feed what we want into the digester, but not what we don't want? So, i.e., packaging, garbage, things like that. And I think that's something a lot of wastewater treatment plants struggle with as well when they're taking septic and trucks are coming in and offloading that you have no idea where that truck came from. And so at our home facility at Noblehurst, we actually work with an organization. I can't remember the name of the organization, but it's with folks with developmental disabilities that come and kind of we provide them jobs to do some manual depackaging. And we have a small type of screw press type machine that we put beverages through. And so people are separating out the cardboard from the smaller containers within the cardboard. We're recycling all the cardboard. We kind of run material based on run the food waste based on what type of material it's packaged in. So we'll do all aluminum or all PET to segregate that material out so we can recycle more of it. And it's very much so a manual process. There's goes into a lot goes into it. We process probably at that location between 20 and 30 tons a day. We're depackaging there. So it's somewhat of a smaller scale, but still a pretty good size depackaging operation. And the material that comes out of that after it goes through the digester is still a really clean material that gets spread on fields, gets spread on land, and it there has not been any issue with contamination, contaminants, plastics, microplastics, things of that nature. So it's been a really good success story. We've been operating that since 2015. So going on 6 years now, and it's been a huge success for us, and that's really been kind of the leaping point from natural upcycling. So natural upcycling was started in 2014 in partnership with Noblehurst Farms, and since then we've grown to the size I mentioned earlier, starting with a few grocery stores just mainly to feed this digester you see below. So talk a little bit about our what I'm working with here in Cayuga. So it's a 1.1 million gallon digester. And I think I mentioned that was a 2 million. It's actually just a 1 million gallon digester in Noblehurst. I misspoke there, but this is a 1.1 million gallon digester that is 100% food waste in Cayuga. We've got two Jenbacher 630 kW engines, or engine gensets that are running continuously, and so we take in packaged food waste as well as what we refer to as source separated organics, which would be cleaner organics that is not considered packaged. We run that through a machine called the Tiger Depackager. So it's an Italian machine. It's basically a couple of augers that feed into a centrifuge-like cylinder that kind of push the organics mixed with water, pushes the organic, liquefies the organics, and go out through a screen, and then the packaging goes up through the centrifuge to another auger that augers it out to a discharge point. So through that machine, we can process about 20 tons an hour, and so we can really push a lot of material through this system here, and it's been pretty successful as far as from a food waste processing standpoint. Kind of our bottleneck here is really the digestion. So this facility is the company that owns it likes to call it a legacy facility, meaning they bought it used and they came with, you know, they got what they paid for, essentially. So it was built by the county. The county built the facility in 2010. It was actually primarily designed as a manure digester that was going to be kind of a community digester for a lot of the local dairy farms. Some issues, you know, they worked with a company out of, you know, a private engineer from Germany who, you know, he's got 3 or 4 of these facilities in Europe that are built like this facility. That you know, and I've spoken with the county about this. One of the lures was that this was a one-of-a-kind facility, first of its type, and that was the main impetus behind building this specific model. Which, if any of you are developing digesters, I highly suggest do not go with a first of its kind, or you know, go with something that has been tried and true, and you can go and visit.
Preaching to the choir with these guys. No one wants to be serial number 1.
Digester I see that gets built, everyone says we're proving the model. We're proving the model. This is the first of its kind, and it's like, I wouldn't advertise that. But so the design of the facility, and I don't know if I can get a little bit of feedback here on kind of who my audience here is specifically. I could get into some of the technical details if that's something that's interesting to people. You know, that's kind of where I focus a lot of my attention on, as far as kind of the intricate details of the digester and how it works and mechanical processes and things like that. If that's not something a lot of people are interested in, I can kind of skim past that.
Yeah, I'll open it up then if we do have a couple of operators on, if you guys are interested in that. But I had a quick question before I forget, Michael. So you mentioned some other end uses, not just land application of the end product, but bedding or some. What are the kinds of things are you looking at for end uses?
On a lot of digesters, dairy-based digesters, what they do is after the digestion process, they run it through a solid liquid separator, just a screw press separator. The liquids, a lot of the nitrogen and phosphorus, you know, remains with or the NPK remains with the liquid. It actually gets rid of a lot of the phosphorus, actually sticks with the solids, but it becomes a really balanced nutrient profile on the liquids when looking at field application. For the liquid side of things, the solid is a kind of aseptic material. You know, after it comes out of the digester, it doesn't have any, you know, bad bacteria in it. When, you know, it all gets killed off during the digestion process, pathogen kill, things of that nature, and it can actually get used, the fibrous material gets used as bedding for the dairy cows. And then it kind of just recycles back into the system. And it's a great way to now I should mention you can do that without digestion. You can do that with just dairy manure and separate the solids and the liquids, and there are farms that do that. It's just a lot more intensive management process, because there's a lot higher likelihood of having a bacterial infection with the cows, because it creates a hotbed for bacteria. It can be done, and it's being done a lot of places. It's just a little bit more management intensive.
So there are a couple questions in the chat. One is from Lee, and I think if you guys want to turn on your microphones too and chime in, maybe if you're not familiar with Zoom, there's down at the bottom, there's a thing, reactions, where you could raise your hand, so then we won't be interrupting each other. But Lee from Northern Tilth was curious about the characteristics of the Cayuga, I'm not pronouncing that right, the digester, that make it challenging to work with.
Yeah, so I have a lot of experience with German digesters. So kind of my first exposure to digesters to begin with at the kind of the start of my career was I spent some time in Germany working on, learning, spent some time at a research facility at Hohenheim University researching hydrogen sulfide removal. It was funny, I came back to the U.S. I had an introduction a little bit in the U.S. with digesters, went to Germany, learned a lot, came back to the U.S. and was like, what is going on here? Why are we doing it this way? This doesn't really make sense. Why, the Germans have been doing this for 20 years. They've got a design that works. Why are we reinventing the wheel? That being said, this design is a German design and it's nothing like I've ever seen before. And so it's very much the quintessential German efficient engineering. So the whole purpose of the way they designed this facility was that it was going to be very energy efficient. So the digester tank itself, so one of the main factors in digestion is, like I said, consistency, but also agitation, proper mixing of the digester vessel itself, and keeping at least in a complete mix type digester. So always keeping in, so if you take for example the digester in the photo below, you have a viewing window, little viewing window, and the goal is to just keep the liquid in there kind of in a slow movement. You don't want to agitate it too much where you're upsetting the reproduction of the bacteria, but you don't want it stagnant where it's just sitting there, because then you get pockets, you get buildup of material. So the way that's achieved in most cases is mechanical agitation. So large, whether it's submersible mixers that get dropped down in from the top, or side mount mixers that have the motor on the outside and penetrate through the wall of the digester and just have a paddle inside. This particular digester doesn't use any of that. It uses what we refer to as biological mixing. So essentially there are two digester tanks. There's a larger tank, and inside that larger tank is a smaller tank. And actually I could probably, if I'm sharing my screen here. Oh, no, I don't want to do that. Let me go here. I can show you a little bit of the representation. Digester tank. So this is a little bit of a representation. And there's quite a bit in red, which I can explain to you afterwards.
We're not seeing that. I think you need to share your window.
Oh, okay. Let me try this.
I think that's how it.
Yeah. There we go. Can you see it now?
Yes. Thank you.
Yep.
Yeah. So this is a view of our SCADA system that controls the. Oh, somebody's on it. Somebody else is doing, so I don't want to upset anything here. So let me get out of that and go 1 second here. Okay, I'll come back here and share my screen. There we go. Okay, don't want to upset any of the operations here. So, you can see from this, can everyone see it now? You can see from this diagram here. So this here is the outer tank, and this is the inner tank. And what happens is material gets fed in through this pipe here into the outer tank. There is a mixer here, but that's not in use. That's not actually intended for operation. I'm not going to get into that right now. It gets fed into here, and what happens is this tank is this pipe here is a gas connection between the inner and the outer tank. Other than this connection here, there's a valve that closes that connection. They're completely sealed off from each other. So what happens is in this outer tank, the first the first material that comes in here, it starts producing the most amount of gas. It's got the most gas potential. When it gets fed in, it produces gas. So what happens is gas pressure builds in the headspace up here. And as the pressure builds in gas, it pushes the liquid volume down through these baffles in the bottom. And so as the liquid comes through here, the liquid level in the center tank, or in the inner tank, as we call it, flows up. And so this tank actually has a gas outlet to another gas storage bubble that's always open, that's always collecting. So it pushes the gas out into the gas bubble, and the liquid level goes up. When this pressure differential between these two tanks reaches a certain point, this valve opens up and it equalizes the pressure between the two tanks, and this liquid level drops in the inner tank, rises in the outer tank, and it goes through these back through these baffles in the floor, which you can't see in this picture representation, but it essentially creates a vortex. It kind of goes through these baffles in a specific manner. It creates a vortex of material as it comes back up, and that's how mixing is achieved in this tank. And so what happens is when you're building gas pressure in the outer tank, it pushes the liquid level up. It actually overflows into this pipe, which then is when it exits the digester. And so material gets fed in here. It essentially gets pushed through this process, sloshes back and forth between the two tanks for a period of time, and then eventually will make its way up to the top of this one and out into the rest of the, into our effluent. We actually have another tank we call the post-fermenter, which is a very common thing in Germany, not as common in the US. It's essentially just a secondary reactor that the material has more of a chance to stabilize before we export it off of the site here. So one of the great benefits of this type of agitation is it uses very little input of energy. So we're not using a lot of electrical motors. All we're controlling is this valve here, which is a small air valve that doesn't take very much energy input. So from that perspective, it is a very efficient machine. The problem comes in when you have a lot of gas production, right? So you got to get a lot of gas production. You get really great mixing, which causes more gas production, which causes even better mixing, which causes more gas production, right? But when that process flips around, if you, for some reason, have a lower amount of gas production, whether it's something you fed into it, another sort of technical problem, a temperature issue, any sort of factor that can affect your gas production, then your mixing doesn't work as well. And then when your mixing doesn't work as well, you get lower gas production. And then when you get lower gas production, your mixing doesn't work as well. And which it causes this cycle, which can easily become, uncontrollable, vicious cycle down. The other issue, so that's the main design. I don't know as though I'd call it a design flaw, because it's a key design component. But it's very much so a perfect world scenario design. And as a lot of you know, there's no such thing as a perfect world. So any small factor that can go wrong can really cause it to kind of spiral out of control. And kind of mixing that with what I was discussing earlier about it being a food waste digester, them in of itself being volatile and hard to control, it kind of doesn't work well. I mean, when it's working, it works really well. When it's not working, it really doesn't work. And so so one of the design components was this was designed for manure, not for food waste. And so manure is a lot more stable, a lot more steady. It's honestly pretty easy to run a manure-only digester as far as from a biological standpoint. It's constantly getting re-inoculated with new bacteria, and what you're feeding in is a very consistent. What you're feeding at cows is very consistent. Therefore, what you're feeding into the digester is very consistent. So, that's kind of the major design issue. The other issue is kind of more related to the transition. The transition of management of this particular facility. So, as I mentioned, the county constructed the facility, and without any real clear intentions on how to operate it. I think they received a couple hours of training from the designer, and kind of said, with this state-of-the-art computer system, it runs itself. You just need to check on it. It's just going to take an hour and a half a day, and that's just simply, that's one of the biggest lies in the digester industry is, it runs itself. You just got to check on it. Have somebody check on it a couple times a day, maybe, but especially in food waste digesters. But so they didn't really know what they were doing, what they were getting into. A lot of the dairy farms they were getting manure from were still bedding on sand material. A lot of dairy farms use sand as bedding. It's very kind of a very aseptic material. Not much bacteria grows on it. Sand and digesters don't mix well. You get a lot of settling, a lot of grit, so when they decided, the county ultimately decided they were losing money. One of the other factors was, it was a municipality that, the workers were kind of 9 to 5 and didn't really want to mess with it when they went home at the end of the night. So they'd actually just shut the engine off and turn it on natural gas so it'd keep the digester warm. And so they were spending money on natural gas to run their engines. So financially, it didn't end up making sense for them, and they decided to just kind of turn it off and walk away. And that's exactly what they did, is they turned it off and walked away and left everything full. Didn't winterize anything, didn't empty anything, just kind of washed their hands of it. It sat vacant for 2 or 3 years, I think, before Generate Capital, who owns it now, came in to purchase it. When they came in to purchase it, they had another management company come in and purchase it, or to manage the operations of it. They kind of were financially incentivized to get the thing running as quickly as possible. So they kind of jump-started it, didn't do too many, evaluations on the equipment. We're kind of in it for kind of making the margin off the top. And they, all that to say, we had a lot of issues this past winter with the digester not getting proper mixing, not getting proper heating. Come to find out, we're actually in a shutdown right now. We're doing a digester clean out. Another design flaw was that they did not design it for you to ever access the interior of the digester. And we spoke to the German engineer, who said, well, if it's operated properly, you shouldn't ever have to do that. So we ended up having to cut a giant hole in the side of it's a welded steel tank. We cut about a 10 by 10 hole right in the side of it, and had to get in there with skid steers to clean out. There's about 10 feet of solids build up in the bottom layer right here in the outer tank, and then another 4 feet on top of that in the inside of the inner tank. So was really inhibiting two things: the mixing, these baffles I spoke about earlier down here, just completely plugged. You're not really getting very much material flowing in and out, so you're not getting much mixing. But also, and it's not really depicted well on this drawing here, but the heating pipes are essentially a stainless steel coil that wrap around the exterior of the tank, and there's hot water or glycol that runs through those pipes, and that's how you get the heat transfer. Or if those are covered and built up with solids, you're not getting very much heat transfer. And so we were seeing, you know, a huge discrepancy in temperature between the bottom of the tank and the top of the tank, about a 30-degree difference in temperature. And so it was a major issue. So that's kind of what we're in the middle of doing right now, is cleaning out this tank and evaluating. The other thing is there's some corners cut on construction. So, you know, this is a steel tank. It wasn't built with any sort of lining or coating on the inside. And so anyone that's got experience with biogas knows how corrosive it is. So we're seeing a lot of corrosion, a lot of damage in there, and we're evaluating kind of what the next steps are. So let's see here. So yeah, I mean that's kind of the technical side of this particular digester. The kind of unique aspects of it. Any other questions on in terms of that?
That was super helpful and informative. Thank you.
Yeah.
Thanks, Mike. I don't really have any more questions on the technical side because I'm still trying to wrap my head around what exactly you were just saying with all that. So,
I have that problem.
I've never designed a digester before, so I don't quite know. But my questions were more related to the market research side of it, the digestion market. How many like farms in the U.S. have digesters, and like how many like municipalities have digesters, and how many?
So on-farm digesters, I know there's like 30 in New York State. In the overall the U.S., so I don't know the number of municipalities. Janine might know that number better. But on farm and kind of manure-based digesters, there's maybe 500 or 600.
Okay, cool.
And that don't quote me on that.
Yeah, I will. I'll use that as an estimate.
Yeah.
Michael, can you share what knowledge you have about drivers for getting food waste to digesters, like states that maybe are
I thought,
pushing that?
For example, you were talking about drivers that drive the food waste to the digester.
Yes. Yeah.
That's why I was a little bit late to me this morning. I ended up having to actually jump in one of our collection trucks and run around this morning. So I've got a lot to say about truck drivers. Talking about kind of drivers for states. So you know, in the Northeast and you know, New England specifically, there's been a large push, and I'm sure all of you are somewhat familiar with the landfill bans that are coming into effect. Some of them, like Massachusetts, Vermont, are already well underway. New York passed the ban in 2019. Yeah, it was kind of funny. It was my company has been involved with kind of lobbying for that effort. Obviously, it would benefit us quite greatly. But it kind of passed by surprise. So it would come into proposal every year, and get picked apart. And then eventually, it would be used as a bargaining token for some other thing, and it wouldn't pass. What happened was that the Governor Cuomo, actually kind of I don't want to say he snuck it in, but he kind of snuck it in with the budget in 2019 when he was passing the budget, along with the single-use plastic bag ban at grocery store, and I thought it was a little comical. There was a lot of publicity about the plastic bag ban. Nobody really paid attention to the organics ban. I don't think really people understood what that meant or what it was saying. So the legislation that was just passed in New York State stipulates that any facility or any organization that generates over 2 tons of food waste per week has to send that material either to anaerobic digestion or composting, or animal feed. Actually, they use the food waste hierarchy, which goes feeding humans, feeding animals, digestion, compost, and then landfill as the last place. So with that, a lot of that comes into effect in 2022, January 1st, 2022. Is when the first round of that, and I know there's intentions of actually over time ratcheting that number down, the 2 tons per week, down all the way till we get to the residential side of things. But they're kind of as a starting point, kind of medium to larger scale generators. Now, a lot of organizations that meet that 2,000 or that 2 tons per week, a lot of them are already doing something, and so it's good in a way. A lot of them are already participating in animal feed operations, food donation, and kind of my company provides the last aspect of that is once you we don't want to compete with animal feed, we don't want to compete with food donation either. So one of the factors with the legislation in New York is there are quite a few loopholes in that legislation. So, for example, the organization in question has to be within 20 miles of a facility that can handle food waste as a food waste processor. So whether it's a compost site or a digester, municipal, private, or something like that.
So if they're not within 20 miles, they don't have to do it?
Correct.
Ah.
Yeah. So that's actually a pretty big loophole. I mentioned we were involved with lobbying for this legislation, and I would always laugh. One of my one of the things my company does is we're very involved in the compost and food recycling, obviously, world, and so we're always looking for more capacity to be able to, whether it's a municipal plant or a private composter or somewhere to bring the food waste. That's kind of right now the biggest barrier to entry for a lot of these materials is processing capacity. And so I would go to these meetings in Albany where they would say, they'd be talking about, and at the time of discussion, it was 40 miles. And then when it got passed, it got knocked down to 20 miles. So went in the wrong direction. But, they would say, yeah, no, that actually encompasses a lot of food waste manufacturing. I said, well, there is not a facility within 40 miles of where we're sitting right now in Albany that can process this material. And they said, well, yes, there are. Just look at this map we made that shows all these facilities. I said, well, I don't know where you got those facilities, but none of them, at least when I call them, will accept food waste. And so theirs were based on who has or holds the proper permits that would be required to take food waste, not necessarily who is actually taking food waste. And the other aspect to that, at least in my line of business, when I'm, as I mentioned, our trucks are doing kind of medium to large scale collection. So, a local composter, I get reached out to every day by developers and or small farms that are starting composting. They say, we really would like to secure some food waste. They said, all right, well, how much would you like? And they say, well, bring me as much as you can give us. All right, if you insist, and I take one truckload, a 10-ton truckload there and dump it, and they said, whoa, how often do you have that? I said, well, at least 4 to 5 days a week. And they said, all right, well, this will last us a month, and we'll call you again in a month. And so So there's that small scale too, but really, you know, where the opportunity is in the large scale, you know, kind of being able to handle those large volumes. And so we've had success with several municipalities, particularly Oneida Herkimer Solid Waste is the kind of the solid waste division. They're running it through repackaging as well. And they're sending their material to the Oneida Herkimer County wastewater treatment plant, which is going through quite a bit of large scaling and scaling up right now to be able to handle new volumes. So we've had some good success with those municipals. We've had bad success with municipals. You know, where like I mentioned with the case when this facility was with Cayuga County, you know, there weren't really any financial motives or financial incentives to be able to take food waste. When you're dealing with food waste and digestion, you have to want to do it. You have to have motivation. You have to have incentive to take the material. If you're not financially incentivized to do it, and the second, you know, a load of baby food powder or baby, you know, formula mix plugs one of your pumps, you're going to say, this isn't worth it. I'm not going to rebuild a pump every time I have to take in baby food. We're not going to accept anything.
What makes them motivated to take food waste?
That's a good question. I'm working on that. So it's really hard to, you know, at a private company, private scale, obviously it's tipping fees. But on a municipal side, I'm not sure what, I guess public pressure maybe. I'm not sure what would motivate a municipality to take that.
You got to have a champion.
Yeah,
and
exactly.
that's what it comes down to.
Yep. And then and exactly to your point, Janine, every municipality that we've had good success with has been one person that's really been fighting for it and making it happen.
Yep.
On the food waste side, is there a lot of nutrient recovery systems that are put in after the digestion, or is that more common in the manure and other digesters?
So it's not common at all,
okay.
Actually. So it is more, to your point, it is more common in manure systems. There's, it's kind of been the holy grail of you know, manure systems is I want a magic box that I put my manure in and out comes perfect, you know, liquid nitrogen, perfect phosphorus and perfect potassium, and I've got no other exports, and I can just apply on my land when I want. That doesn't exist yet. There's a lot of systems out there that claim to be the answer, but there's, you know, and it's something I'm kind of on the, I don't want to say I'm on the front line on, but I'm on the second line, the right behind the front line, kind of following along. So my, you know, as I mentioned, my background and a lot of my experiences related to dairy, previous to this. At one point in my career, I was actually working on a dairy as a manure nutrient planner. So I was in charge of government reporting for what was being put on the fields, what the farm was producing. And so in that, I was in a constant search for, you know, a better way. And so my brother, so my family is kind of involved in dairy. My older brother is actually a manager on a 15,000 cow dairy out in the Midwest, and so I'm always called on by him as his manure consultant when he has, you know, salesmen or people approaching him about nutrient separation, digestion, all of those factors. And it's funny, there's this one type of technology. I'm not going to mention the name, but they sound very exciting, and we went to try to tour it, and they said, well, we're not quite ready for tours yet. Well, that just means it's not working yet. And so I've seen it more on the dairy side of things. There is technology out there. but it takes just as much, or if not more, management than a digester does to run a process.
Okay. The reason I'm asking is because the company I work at, we're working on nutrient recovery in dairy manure. Which
company is that, if you don't mind me asking?
It's called Zwitterco. We're not a whole system provider, but we work as a membrane component for that system.
Oh, okay. What was the name of the system? I'm sorry, I didn't hear you.
Well, the company is Zwitterco, Zwitterco.
Okay.
It's a relatively new startup that Brendan's involved with.
So we're working on that now. Yeah.
Well, let me know. I would be very interested. And so when right now traditionally a lot of food waste digestion is happening on farms. And the way we look at it is the food comes from the ground, we grow it, the farms are providing the food. It makes sense for those nutrients to go back to the land. And that's really our goal at Natural Upcycling. That's kind of our mission, is to get those nutrients back where they're supposed to be, rather than piling them up in a landfill where they're just going to cause issues when they're valuable nutrients. That being said, there's a growing kind of movement of food waste only digestion that are kind of what I would refer to, or what we would refer to as merchant digesters, that are not, that is their only business, is digesting, processing food waste. And in those facilities, one of their largest challenges is, what do we do with this material after it's done? Where when you build a digester on a dairy farm, you've got the land, you've got the resources for spreading that material, you've got the resources for harvesting the crops. Whereas a merchant digester, they own a 5-acre plot of land with a bunch of tanks on it, and after it gets done with the process, they're begging to the local farmers, can you take this? Can you take this? And farms take it, they want the nutrients, but it's not a top priority. So this whole nutrient recovery thing, if it makes financial sense, would make perfect sense to to have a material after digestion that is then a saleable material. And I think we're a long way, and maybe you have inside knowledge that I don't, but I think we're a really long way away from that, from a commercial standpoint.
Okay.
Yeah, I would agree. I have another question for you, Mike. I'm just curious if you've ever been involved with a facility where there was a catastrophic event at all, and what was the cause of that? I'm just
catastrophic.
Yeah, either a failure, explosion, anything like that.
So I have not well, I was involved with one. I've been involved with a few membranes flying off. The gas holding membranes coming off. We had a blowout in a facility I was working with a few years ago where we found a bullet hole in the membrane itself.
A bullet hole?
A bullet hole, yeah. Luckily, that did not cause an explosion, but it did cause quite a bit of damage to the membrane itself, where in essence they had to get replaced. At this facility, we've had quite previous to me being involved, of course, we had some overpressuring events on some tanks, on the gas storage tanks that actually, the gas storage tanks are very low pressure. They're measured in inches of water column. And so it's very low pressure, but it's really surprising how much such little pressure can do when applied to the right forces. We have a couple concrete tanks here. The overpressure protection got foamed over or plugged for some reason, so it didn't work properly, and it ended up cracking the sidewall, 6-inch concrete sidewall. And in those scenarios, it caused quite a bit of damage. Luckily, there was no catastrophic events, no explosions. I've heard of Fires. So I know at this facility, when it was owned by the county, there was a fire at one point in the electrical room. That was due to a leaking gas blower. So another kind of poor design. I wasn't going to blame this on the Germans, but you know, the engineering company that put it together, they put the gas blower right next to the electrical room where they had issues with the gas blower with it leaking. And so gas, hydrogen sulfide, methane was seeping into the electrical room, which is a very, very dangerous situation and can be cause for an explosion hazard. Obviously, with electrical equipment, you have high chance for spark, arcing, things like that, and if any gas is present. And not to mention the methane gas, but even the hydrogen sulfide causes major issues, causes a lot of corrosion. And when you've got copper wires and aluminum wiring, you know, it corrodes very easily, causes, so we're still dealing with that poor decision. We've moved the gas out of that room. We're handling it completely different now, but we're still dealing with electrical malfunctions due to corroded wires from the hydrogen sulfide.
I have another question.
Sure.
This is really interesting. So obviously you have SCADA to run this thing, but Nedr is involved in a research project right now to bring in AI, machine learning, and AI, you know, artificial intelligence into operating these things to try and learn how they operate. Can you talk to that at all, or is that important? Is it not important?
AI, other than the fact, so Generate Capital, the company that owns this facility, is very interested in data, and for good reason. I actually think they're the largest single owner of anaerobic digesters in North America. So they own, and that being said, I think they own maybe 6 or 7 facilities. So, but what they're doing, one of their big pushes is for collecting all of the data from those facilities. Every single data point they can get their hands on to be able to kind of aggregate that data, learn from it, and create, you know, universal systems and kind of metrics to measure systems by on efficiency, on capital efficiency, on energy efficiency, operational efficiency. That being said, we did do an experiment here last year with, now I can't remember the name of the equipment, but it's essentially a headset that you wear with kind of like Google Glass, where one piece goes over your eye, and if you have it set up right, when you're looking at it, you don't even see the headset, it will project images in front of you. So that uses a little bit of AI, and what it's used for. So it has a lot of different applications from an operational standpoint. And Janine, I can get you the name of this technology. I can't remember it off the top of my head right now.
Yeah.
But say I'm walking around my plant, I can look over at my tank, and it can transpose these numbers: temperature, volume, levels, anything. I can transpose it where I look at that tank. That's what I see. I can look at a pipe. I can see if material is flowing through it, or what temperature that material is, or where it's coming from, where it's going. If I, you know, so any sort of sensor data that I'm already collecting, I can transpose that in kind of an AI format or it's not AI necessarily, more
human-centered intelligence. Yes.
Augmented reality. Augmented reality is the term I'm looking for. So the other thing with that is, say I've got a new employee at a plant that and the engine breaks down. I can be in California, and I can get on my computer, and I can see exactly what he's looking at on that engine.
Oh.
And, you know, using my computer, say, here, you want to open this valve here. You know, if you're changing the oil, open this valve, close this one, and on his screen, or as he's looking at that engine, he sees transposed in front of him an arrow pointing to this valve right here, or this, and I can, or even, you know, if I'm working on something, I can see out of the corner of my eye a tutorial video on how to fix that, or something like that.
Huh.
Or even, you know, it's versatile enough where, you know, even down to the lowest use of it would be as a cellular headset, to where I'm on the phone with a technical support at a company, and they're just on their phone talking me through it, but I'm there, I'm hands-free. Obviously, that's not very sophisticated, but it's still a use for this technology. So we, to get to those levels, takes a lot of input. It takes a lot of work to set that type of those processes and systems up. I think that's a goal here in the long run. It's just, you know, how you prioritize things. The other issue that we had when we were experimenting with it, that you know, some of the biggest problems are the simplest ones. It can be easy to fix, but we got it kind of dialed in to where we had it working, and or to a level, to a certain extent. And we said, all right, let's go test this thing out. I walked outside a Wi-Fi range, and I dropped my signal, and it didn't work at all. So, you know, a simple fix as far as extending the Wi-Fi to, you know, different parts of the plant, but it can be made more complicated for when I got a different Wi-Fi, you know, connection in this electrical room, because it's a big concrete room that can't get a signal through. So small, you know, easily
Little details.
Little details that you know, a lot of times easily overlooked can cause with that type of technology.
It's all about the details. But yes, please share that information with me. I would really appreciate it. So at this point, is anyone else have any other questions? We are running a little over, but this was very interesting. If there aren't any other questions, then I just really want to thank you, Michael, for sharing your knowledge and expertise with our little round table here. And thanks to everyone who joined us. We hope to see you next quarter. We're going to have a presentation about the environmental